Learning objectives. In this chapter, the user would learn the following in detail: mobile agents, gateways, service discovery, device management, mobile file system. Device management (DM). There are many types of devices in a mobile network managed by a mobile service provider. Device management means the following: configuring at initialization, bootstrapping, monitoring current configuration, processing maintenance requests, taking care of location, handover of each device. Device management in pervasive computing environment means managing the infrastructure of a large number of networks at the same time. Each device can have applications downloaded from different sources in an enterprise. The service provider has to manage and serve the applications. Each device may subscribe to different types of services for different durations. For example, a device may subscribe to specific gaming applications for a month. The account and authentication of each device is managed invisibly without system administrator. Device is self-administered. It boots up, starts the operating system, initiates accesses, establishes secure connections, and terminates the connections. Runs through a setup phase, exchanges packages to get the allocated network and system access addresses. Each device in a mobile computing system interacts with the other, has features of self-healing and self-configuring network. Device support infrastructure. Tivoli Device Support Infrastructure (DSI) is a IBM software used for ATMs, handheld devices, set-top boxes, and cable modems. A device gateway has a device management agent to connect devices at one end with the gateway at other end. The gateway includes Tivoli Management Gateway. Connects to device management server of the service provider. DSI Device Manager assigns a unique ID to a device. Also, local ID to the device, which is supported by the support infrastructure. Unique ID remains fixed. Assigned once. Local ID can be reassigned when the device moves from one personal area network to another. Saves device information. When a number of devices are of identical types, for example, smartphones type, then a group object can be used by assigning the same type of devices to a group. The object then manages large number of devices of same type. Figure below shows IBM Tivoli Device Support Infrastructure Architecture. User, device, and network profiles. Profiles provide a specification for the use of software such as Device Manager or Device Management Server. Device management requires profiles for the user, device, and network. Mobile Information Device Profile (MIDP) provides a specification for the mobile devices such as mobile phone to enable the use of Java Micro Edition programming framework. User Profile consists of user password and ID. A user can also add PIM data, individual preferences, and security credentials to the profile. Facilitates device management by system access to user profile. Device Profile. Device Profile includes a unique ID, local ID, individual preferences, and available resources accessed by Device Manager. Network Profile accessed by Device Manager. Network Profile specifies the current location address of the device and networked devices and the description of the network services. information provided by profiles. Includes specifications of groups, services, names, and objects. A profile may give descriptions of the types of the devices which can group and be managed concurrently. A profile may give descriptions of the services at the devices in the network. A profile may include the names, services, and object names. Directory service. A service means a software or protocol for specifications and provisions for a set of operations with a given objects or entries. Directory service means a service protocol which specifies and provisions for the set of operations with the given objects or entries in a directory. Directory. An efficient way of storing and accessing data. Has a tree-like structure with entries at the tree leaves and nodes representing the printers, documents, persons, organizational units, groups of persons, or anything else which may represent a given entry or multiple entries at the tree. A tree has a root with numbers of nodes. Every root object is a parent which has multiple child objects. At the end of hierarchy, there is the last child object called leaf. A child object or leaf object. Each one identified by a URI, Universal Resource Identifier, in a function method. For example, assume that A is root object and it has child objects B1, B2 and B3. B1 has children C1 and C2 and assume that C1 is a leaf object. URI for C1 is A.B1.C1. URI specifies the hierarchy position of a node and a consideration with respect to the root, used when referring to an object in a function or method. Relative URI means specification relative to a present node, not necessarily from the root. An object accessed by its name and attributes. Name is referred to as DN, distinguished name for the object. Each attribute is also named. LDAP, Lightweight Directory Access Protocol. An open source networking protocol for accessing, modifying and querying TCP/IP directory services. Its current version is LDAPv3. Lightweight means that the protocol does not depend on OS and system resources. Accessing, querying or modifying an object in LDAP can involve a tree of directory entries, each of which consists of a set of named attributes with values. Some attributes are mandatory and some optional. LDAP basic operations. Most services use LDAP as a simple starting point for their database organization. Bind, start TLS, Transport Layer Security Protocol, add entry, delete an entry, modify DN, abandon to abort an earlier request, search, compare, extend and unbind. Bind, an operation, function or method to link an accessing object with the accessed object. Without successful bind operation, the directory entries objects cannot be accessed, modified or queried. OMA DM, Open Mobile Alliance Device Management. OMA DM objects most used standard in mobile device computing system. DM defines a description framework and has hierarchical structure in which there is a management object tree. DM is based on SyncML Data Synchronization SyncML DS specifications. In a hierarchical structure for the management objects, the OMA DM protocol standard provides for specifying how many times how many children of a parent an object node can occur in the hierarchy. Example, client username, username of client which server recognizes, and client PW, password using which server authenticates a client before providing the service, specified in OMA-DM as having 0 or 1 occurrences. DSA-CC, Data Synchronization Account. Parent node of a management object for data synchronization. The child objects nodes and leaves objects for DSA-CC of the parent object DSA-CC with specifications for their occurrences and functions methods required for their accessibility. Figure shows SyncML DM stack. Gateway. A gateway connects two networks, each using different protocols in its network layers. A GPRS mobile service network deploys SDSNs serving GPRS support nodes. A SDSN interface to BSEs, base station controllers. The SDSNs, on the other hand, interfaces to GGSNs, gateway GPRS support nodes. On the other hand, GGSNs connect to a packet data network like Internet. Protocol Conversion Gateway. Connection gateway software is used to connect two application layers using two different protocols. Connects client application and application server. Figure below shows a WAP or IBM Secure Way wireless gateway between wireless devices, the Internet, and application server-based N-tier architecture, where N is greater than or equal to 3, with requests processed at the application server using back-end databases and system. Figure shows WAP or IBM Security Way wireless gateway. Tier 1. Tier 1 client consists of a client using WML, wireless markup language, when the client seeks WAP messages. The client sends the application service request and obtains the responses. WSP, Wireless Session Protocol, establishes a session between the application server AS at the Internet and the clients. A client sends a request for the service required by collaborating or independent mobile devices or a mobile computing system. Tier 2. Tier 2 application server AS connects to the Tier 1 through the Internet. The Internet end uses TCP/IP, while the wireless device ends use WAP or other protocols. When the protocol used is WAP, a gateway which connects Tier 1 to Internet, which has the AS, is called WAP gateway. IBM Secure Way wireless gateway. A WAP gateway which connects these two tiers 1 and 2. The connection established through WSP. IBM WebSphere consists of partner gateway and is used for the connections and transcoding between the tiers. Use of Funambole for developing the mobile computing applications. The connector objects provide the gateways. The gateways connect to the file systems, databases, email systems, and applications. Use of two-way synchronization with existing data assets. Connector objects in Funambole also provide gateways for data stores, databases, files, and email systems. Transcoding gateway or proxy. Transcoding gateway. A gateway is called a transcoding when it adapts its response to the content format of the client device and requests to it in the format required by the application running on the application server. Transcoding proxy. It has conversion, computational and analyzing capabilities, while a gateway has conversion and computational capabilities only, and a proxy can execute itself on the client system or application server. Transcoding gateway applications. format, data, and code conversions from one end to another when the multimedia data transferred from a server to the mobile TV, internet TV, web phone, and smartphone as the client devices. Filtering, compression, decompression, configurable transcoding gateway to provide authoring and deployment, used for converting XML style sheets to WML or HTML, video to images, image to hyperlink, one image format to another, scaling, mapping, and color adaptation, facilitates TTS, text-to-speech conversion, and STT, speech-to-text conversion. Residential gateway, a wireless device which provides connectivity through a service provider. The network also connects to application servers and backend server through the internet. Residential gateway is a gateway between a network of home devices and the outside world. Home has a number of systems: cable TV or set-top box, personal computer, laptop, digital camera, iPod, home theater, iPhone or mobile phone, and Bluetooth-enabled appliances. These form a home network. Outside world typically consists of internet, enterprise server, backend database servers, and application servers. Consists of high-speed internet IPv6. Figure shows residential gateway architecture. Mobile agent consists of software with data which can move from one computing system to another autonomously. Functions for a device or system on the present host. Described as an autonomous software which runs on a host with some data. Dynamically moving software to another host which has other required data as and when required. A powerful tool for distributed applications and retrieval of remote host information. Has dynamic software that runs on different hosts at different times. Makes available the resources of its host to the resource-scarce devices, discovers new resources, and monitors the distribution of resources. Also manages the network and the distributed computing systems. Very effective alternative to the use of application-specific servers and device middleware for retrieving information and messages. Example of a mobile agent-based architecture. Agent moves at instance T1, T2, and T3 to process a request, get email, and get records from a database respectively. When a mobile agent moves at instant T1, T2, or T3, it saves its own state at the host and transmits this saved state to the next host in order to resume execution of the codes starting from the saved state. Figure shows a mobile agent-based architecture. Peer-to-peer architecture. A device can have an agent at the host that can send a request to and get a response from the other. Each device can have access to database or database servers. Figure shows peer-to-peer architecture. Characteristics of a mobile agent. Mobility of code and data from one computing system host to another. Ability to learn in order to adapt code and data to the host computing system. Ability to clone, extend, or dispose itself after its role finishes. Compatibility to the hosts. Ability to continuously and autonomously process requests and send responses and alerts. An alert is an unsolicited message, record, or information. Mobile Agent Technology, Agent OS. Agent OS, an operating system developed in 2006. Provides application virtualization environment. Allows automatic thread migration, ATM. the threads running on the host being independent of the OS. Advantages of a mobile agent. Asynchronous running of codes on diversified heterogeneous hosts. Reduced computational and data requirements on the devices with limited resources. Tolerance to connection failures. Only the agent source, for example, device middleware which sends the agent, needs to be modified in order to redefine the functions expected from the agent. There is no need of a centralized or an application-specific server. An agent can send the request to a computing system as well as generate responses for requests from the system. An agent thus has certain similarities to peer-to-peer architecture. The connection protocol and the connecting network between host and source are immaterial. Issues in use of agent. An agent may have strong or weak mobility. An agent possesses migration and collaboration latencies. Migration latency means waiting period in migrating from one host to another. Collaboration latency means waiting period in start of collaboration between the application server and the service requesting system. There can be environment and platform-specific difficulties in implementing adaptability and compatibility at diversified hosts. In addition, security-specific issues related to an agent moving from one host to another. Mobile file systems. File system. A method of organizing and storing files on a storage device at computer or mobile device. Basic middleware which firmly couples to an OS. Consists of file functions, methods for handling and transferring files, and file descriptor. File system functions are must for accessing data using file name or directory. Enables direct access to data regions on a storage device. File system designed for a mobile device is called mobile file system. Maybe a phone or smart card or flash memory stick, SD or micro SD card. Features of file system. Hierarchical organization, storage, modification, navigation, access and retrieval of files. Easy search and access of files. Maintenance of physical location of files on a storage device. System functions uses the data from a file server software in response to client requests. Technology similar to that of databases. Scalability. Security, access control, authentication and encryption. CODA. It is a distributed file system. Developed at Carnegie Mellon University CMU. Can be considered as CMU Object File Data Access System for wireless environment. CODA file system architecture. Files on a CODA server are organized by partitioning the server. Partitions will contain files grouped into volumes. Volume, logical unit of files. Single server would have hundreds of volumes. Files in each volume have a tree-like directory structure. There is a root directory for the volume. Root has branches and root directory has subdirectories at the branches. Last branch is called leaf. 3 states of a connection to the clients to which files are distributed by a server are disconnection, weak low bandwidth connection, strong large bandwidth connection. CODA file system disconnected operations. Integration takes place in case of disconnection. Means merging objects received from a connection at different instants. Server sends data repeatedly in broadcast disk model. Data which could not be cached earlier gets cached later and integrates with previously received file records. Trickle reintegration takes place in case of weak connection, means adding the objects received at smaller bandwidth. Data trickles and integrates into a large file and continuously reintegrates. Hoarding takes place in case of strong connection, means collecting objects received at large bandwidth. This helps in eventuality of disconnection. CODA file system deficiencies assumes that mostly one user writes the data into a file. Each change is not tracked. Detects at an instant the conflicts only when a different user is changing a file. This facilitates reintegration of file data from users. There is inconsistency if a file is being read at the same time when reintegration is taking place. Hoarding is not permitted in case of weak connection. Service discovery. An adaptable middleware in a device or a mobile computing system that dynamically discovers services. Bluetooth Service Discovery Protocol, JINI SLP Service Location Protocol, and UPnP Universal Plug and Play have the functions of service discovery. Steps for service discovery. Let's nearby service network or device or system recognize that device. Lets the nearby network know of device services. Searches and discovers a new services at the network. Interacting with nearby network using discovered services. A self-administration software performs following actions. Software for starting the operating system. Allocating network and system access addresses. Initiating accesses. Establishing and terminating the connections. Making secure connections by the provisions by a system on its own without using network administration software when connecting to a network. Service discovery middleware supports self-healing and self-configuring. Self-configuration means establishing and modifying the root information from the connections to a system on its own. Self-healing network means that the network can establish an alternative route when a connection or en route node breaks. The discovery of the neighboring devices and server and interactions done without administering the device. Bluetooth Self-Discovery Protocol SDP. Bluetooth-enabled digital camera placed near a Bluetooth-enabled PC discovers that the PC is Bluetooth-enabled using Bluetooth Service Discovery. The camera exchanges information with the PC, which downloads the pictures or video clips onto it. Bluetooth-enabled PC discovering Wi-Fi LAN. Downloads MP3 files from the broadband internet. Service discovery in iPod. When placed near it, the PC transfers the media files to iPod. The user can now listen to selected music when mobile. The iPod can also download photo albums and iTunes from the PC or network. JINI Sun Microsystems Open Architecture Network Technology. Responsibility now transferred to Apache. JINI performs following actions. Enables the programming for the distributed computing system environment. Enables programming of mobile devices and server. Enables developing modular and cooperating. Enables the download of classes for the service components. JINI provisions for not only service discovery but also for the lookup for the databases. RMIs, remote method invocations, and the joining, binding of APIs. Programs of a device with those of other devices discovered using the lookups. JINI, Java Spaces Technology. A simple and powerful high-level tool included in JINI. JINI is used for programming collaborative and distributed applications. Shares network-based object spaces. JINI, Java Spaces Technology Object Space, associates memory for the distributed objects on the network, used both for object storage and as exchange area. Communicating nodes use the space indirectly. It creates a simple API for use by source and destination nodes. JINI also includes Extensible Remote Invocation, JINI-ERI. Enables programming and dynamic computing in a device and provides a platform to create adaptable, scalable, evolvable, and flexible network-centric services. Highly adaptive to changes in software and hardware. Provides spontaneous interactions between devices and network. A discovery protocol may or may not provide the facility of device querying, but JINI makes it possible using the pairs. Service Location Protocol SLP enables client device to dynamically discover a service. SLP stack consists of SLP header and SLP service URL, Universal Resource Locator. A URL is a universally accepted unique identifier for a resource and thus a location. SLP URL enables other devices to use the service of the client device. Provides the location of the device in the network. It advertises its service needs in multicast mode and does not use directory service. An alternative to look up service database in JINI or a service catalog. It provides Java classes, program codes to a client device. SLP differences from JINI. SLP just provides the lookup for the URLs and description of other devices during discovery phase. Does not provide for database lookup, join, and spaces as JINI. Description specifies a service. Device textual description at a lookup database service or service catalog enables a new device to use as a service of a specific device. It is uploaded at the database when a new device joins a network and is downloaded to the new device to let the device discover the services. It can be in XML. Unicasting Service Discovery. Unicast using TCP/IP or any other SDP means that the service discovery is directly by connecting to the lookup service database/descriptions. Each device as well as lookup service has a URL. These interact through unicasting. Multicasting service discovery means service discovery by a broadcast of the description of the service to a group of devices. The directory, service catalog, or service database descriptions multicast and enables service discovery. Multiple nodes get to a service directory, service catalog, or service database descriptions. Each device can use a multicast message to discover a service. Multicast permits dynamic service discovery. A device receiving a multicast message for a new service uses it to discover that new service. Advertisement for service discovery means a device need not discover a service. or new device establishing a connection to a network advertises its services. A device disconnecting from the network advertises its disconnection. In this way, each device maintains the database or descriptions of the services presently available. Universal Plug and Play (UPnP), a Microsoft solution for service discovery, for service and device descriptions, for use of control points, for control for registering the subscription events and withdrawal after subscribed interval, for presentation and event notifications called venting. UPnP includes description and its clients are called control points. Control point registry, a registry for any device establishing connection with the network or disconnecting from the network. Provides descriptions and URLs of all devices presently connected to the network and makes available the service of a newly connected device to all other devices. Does not allow device querying. Provides only descriptions of device service. Chart below shows UPnP core protocols for the service discovery, description, control, and eventing. Conclusion. In this chapter, we have covered the following in detail: mobile agents, gateways, service discovery, device management, mobile file system.